Hello friends! Alright, we're going to do some integration by substitution. These problems are taken from a math.ksu.edu page that I will try to cite in the description here. So the first question, integral x cubed 4 plus x to the fourth dx. So in this case, I can look at this problem and I can say, well, if I look at that, the derivative of the inside there is essentially sitting right here because I have an x to the fourth, and that will become an x to the cubed. Ignoring constants, that doesn't matter that much. And then the derivative of 4 is just 0. So my u is going to be 4 plus x to the fourth, which makes my du dx 4x cubed. And for many of my students, what they like to do is they like to solve for dx and call that du over 4x cubed. They're treating it kind of like fractions. They're not, but we can kind of treat them that way. So then I'll have an x cubed, and then a square root of u now, and then a du over 4x cubed. And conveniently, these x cubes will cancel. So I can rewrite this integral as 1/4 integral. Square root sometimes freaks out my students, so we'll write that as to the 1/2, and then du. So now we just do power rule. Well, reverse power rule, I guess. So we have u to the 1/2, so that's going to be u to the 3/2, because 1/2 plus 1 is 3/2. Compensate out front with a 2/3. Don't forget, I need that 1/4 also. Now that 2/3 is there because 2/3 times 3/2 is 1. And don't forget plus c. Many of my students forget that. And then 1, so that's 1/6. And u was 4 plus x to the fourth to the 3/2 plus c. And that is all I have to do for that problem. For my next problem, I have, the way the problem's originally written is dx x natural log of x. This shows up in a whole bunch of places. Well, I can think of that, if I choose, as 1 over x times 1 over the natural log of x dx. Now, the reason that I might suggest breaking things up like that is because what's the derivative of the natural log? That's one you have to know. The derivative of the natural log is 1 over x. That's sitting right here. So I can again use u substitution. I can say u is the natural log, which means that du dx is 1 over x, which means du is, dx, wrong letter, is x du, or x du if you so choose. Let's go ahead and substitute in. I don't have something for 1 over x. I have 1 over the natural log of x, which is u, and then du with an x in front. Oh, look, those x's will cancel, so that goes away with that. Now, if you want to, at this stage here, you could have solved for du and said 1 over x dx, and then replaced the whole 1 over x dx with du. You would get to the same place. If you don't see that, that's totally fine. The process we did was acceptable. We have 1 over u du. Now, whose derivative is that? Well, that's the natural log. So that's the natural log of u plus c. Now, u is the natural log of x. So that's going to be the natural log of the natural log of x plus c. And we're done with that one. The last problem I'm going to do on this one is x plus 5 square root x plus 4 dx. This one has a little bit of spiciness. So you might not recognize u sub right away, but here's how we're going to use u sub. I'm going to say u is the bottom, because if I can just make that the square root of u, that will make my life easier. So that means that du is just dx, or du dx is 1, and then du is equal to dx, depending on how you want to write things. Now, you notice how if I go back and I substitute in, I'm going to have the square root of u, I'm going to have x plus 5, and I'm going to have a du. So now I have a wah-wah, because I have an x plus 5 there. I would like that to not be there. Well, if x plus 4 is u, then x plus 5 is u plus 1, because I can just add 1 to both sides. So instead of x plus 5 on the top here, I can think of that as u plus 1. Now you might be saying, okay, that didn't really help that much. You still have this crazy fraction thing. Well, let's check this out. If we use our algebra skills and we rewrite this as u plus 1 over u to the 1/2, I can divide both pieces by that u to the 1/2. So I can rewrite this as u over u to the 1/2 plus 1 over u to the 1/2 du, which I can then write as u to the 1/2 plus u to the negative 1/2 du. And now, whose derivative is u to the 1/2? Why, that's u to the 3/2, which is with a 2/3 in front. Whose derivative is u to the negative 1/2? That's u to the 1/2, which is 2 in front. And don't forget plus c. And then we have to go back to where we started. So we have 2/3, x plus 4 to the 3/2. That's a 3, I promise. And then 2x plus 4 to the 1/2 plus c.